Right? It shouldn't be any shock. That's everything we've done since the beginning of the unit, which started on February 5th. So it's been, I know we had a break in between, but it's still been a while. It's only going to be 11 questions. I know that doesn't seem like a lot, but you know, you've probably seen from the double triangles and some of the law of sines and cosines, some of them take a while. All right, so that's why there's only 11 of them, 41 points. If you look on the next page of your double triangles homework, you will see a list of formulas, which I will not provide to you. I will provide one formula for you tomorrow, and that is quadratic formula, if you need it. I am not going to provide law of sines, the law of cosines. I'm not going to spell the word SOHCAHTOA for you. All right, I will not provide any of that for you tomorrow. All those laws can be found on the next page of from the double triangles in your packet. You will also need to know your 30, 60, 45, 45, 90 rules. They will not be given to you. And some vocabulary, as you can see there as well. Cofunctions, geometric mean, elevation, and depression. At the bottom of that page in your packet is a list of textbook problems I'm suggesting you try. The more practice, the better. On the next page, you should have the answers to those textbook questions. Just check. Yep. And then after that, you should have additional questions, which we're going to work from today. And at the very last page of your packet, everybody, should be the answers to those additional questions. Just make sure the last page of your packet is the answers to the additional questions, because sometimes things don't get stapled correctly and the last page always gets cut off somehow. All right, so last page there. All right. We are going to get started here. I have a couple of the additional problems we're going to just grind right through. I'm going to hear from almost everybody right now. We're going to start with problem number 1. Go ahead and draw yourself a rhombus. Here we go. Draw yourself a rhombus. I am told that one side of the rhombus is 10 millimeters and one of the angles is 60. So pick an angle, 60 degrees, pick a side, 10 millimeters, because they're all 10 millimeters. It's asking me for the length of each diagonal. Are they going to be the same length? No, that's called a rectangle, not a rhombus. So as I'm drawing these two diagonals, we're going to find the length, and I want you to start thinking about properties of diagonals for a rhombus that are going to help me out in this problem. All right, so one property that you know of a rhombus, 20, bisect each other. So am I really going to find the length of a whole one? No. I'm going to find the length here and do what with it? Double it, multiply it by 2. All right, good. Other properties, because that's not the only one that's going to help me. 20 again. They are perpendicular. That gives me my right triangle, which I could do everything with. And one more property we rarely talk about, but it's going to be helpful here. 14. Rectangle. So now this 60, I'll have a 30-degree angle. What type of triangle have I formed? 30, 60, 90. Let's work. Because what I'm going to do right now is, again, just like Letty said, I'm going to find this side and double it. I'm going to call that X. And I'll find this side and double it. And I'll have both diagonals already. How to find those two, X and Y, you got choices. All right, but unfortunately, I'm going to narrow it down to one choice for you only, and that is the 30, 60, 90 rules. All right, yes, you could use sine, cosine, tangent. You could use law signs. I get it. But I want to go over the 30, 60, 90 rules now. So that's the way we're going to do this problem. All right, refresh. What are my 30, 60, 90 rules? Here you go. 2, my 30, 60, 90 rules. X. Yep. 2x, perfect. And it looks like we're going to find the side across from 30, which is x, and the side across from 60, which is y. All right, so those are the sides I need. What side did I give you? The side across from 90 is 10. Do you have the ability to fill in the rest of the diagram, the rest of the chart now? Okay, what do you got for me in the rest of the chart here? 17, what do you got for me? The rest of the chart? Yep, and across from the 60? Okay, here we go, everyone. So I know x is 5, meaning one diagonal should be, if x is 5, one diagonal length should be how long? 2? Sure. X is 5, meaning this diagonal length here should be 10. So one diagonal, 10. Got it. Y was 5 radical 3. So the other diagonal, or the longer one in this case, will be equal to, what do you got for me, 9? 10. This is 5 radical 3. What did we already discuss? How to find the length of the whole diagonal. Okay, 5 radical 3 times 2. Where's the other radical 3? Ready? I'll write it. 5 radical 3 times 2. There's only one radical 3 there. 10 radical 3. I'm going to warn you, because I know in some minds right now, I'll just use law of sines tomorrow. Okay, but what if I change it? And what if the directions are leave your answer in simplest radical form? Because you use law of sines, what answer are you going to give me? Whatever decimal is on your calculator. Okay, so be aware of that. All right, just don't try to cop out of the 30, 60, and 45, 45, 90 triangles. Because if I say simplest radical form, this is no use to you. All right, the calculator's no use to you. All right, moving on. There's a fireworks problem on number 6 that I want to go to. Okay, you are watching, and you is that red person right there. I guess maybe you got sunburned during the day. I don't know. And you're standing 295 feet behind the launch pad. Can you guys identify where the launch pad is here? Because that's going to be extremely helpful in the rest of the problem if you can identify where the launch pad is in this problem. You, the red person, are standing 290 feet behind it. Everyone identify the launch pad? It's one of the vertices of the triangle. Here you go. There's the launch pad. Then they tell you they shoot them off at 65 degrees and you're viewing it at 40 degrees. Okay, so part A. Nearest foot, what's the horizontal distance from the launch pad to the point where they explode? That's not on here right now, is it? Read the problem again. The horizontal distance from the launch pad to where the point where they explode. That's not, I didn't draw that in for you. Everyone see what I'm looking for here? This distance right here. About. I'll call it A since it's part A. And then if you just look ahead to part B, what's the height of the fireworks when they explode? That's not drawn in either. What's got to be drawn in to find the height where they explode? Another vertical line. Oh, what did we just create here? Double triangles from yesterday. Yeah, double triangles. What are you guys going to try to fill in first? All the angles, go right ahead. I'll do the same for mine. Okay, trying to find A right away. Not going to happen. Somebody tell me what side I can find, though, using all this information. 4, what side can I find? Launch pad to what? Launch pad to the fireworks I can find. This side right here, yep. Launch pad to the fireworks. How do you want to find that side? Here you go. Let's hear from 4 Maeve again. How do you want to find that side? How did we find it yesterday? Okay, go ahead. Pick one triangle where you can give me all the information from. Over. Sine of what? What's across from the 290? Which is? We okay? Okay, what other side am I looking for here? Okay, I have y, that's fine. You have z, and then sine of 40. All right, let's cross them up. Is this going to be your final answer in part A? Nope, don't round then. About 441.0798673. And then what do you want to do to that side to find the horizontal distance? That's what I need to know now. What do you want to do with that side to find the horizontal distance? Because now I have enough info. 11, what can I do now?
You add the side A and side 290 feet. Oh, you subtract 290 from the full side.
Okay, how am I getting to the full side?
Wait, sorry. What do you have?
Yep. It's all right, just continue what you're doing. 20, here we go. Okay, so you want to do law of sines again. Y over sine of 90, yep, equals. Well, I'm sorry, hold on. I don't want to put y in there since I know it already. Here you go. Over the sine of 90, yep. Sine of 25, got it. And again, we're using this right triangle now for all those values. Now, you don't have to use law of sines. You could also use either sine or cosine from SOHCAHTOA. You could do it that way. Bella?
That was my question.
Yep, yes, you can. Yep. The only thing you can't use is tangent. But you could use sine or cosines. And then what are we getting out here? The value of A? We're looking what? Nearest foot? 186 feet. Whew, we got a lot of options to find the vertical distance now. Whew, ton of options. You want to do sines again? Go ahead. You want to do sine, cosine, or tangent? Go ahead. And what else can I even throw in here? I could also do Pythag now. The only thing you shouldn't be telling me is 30, 60, 45, 45, or Hill-Sass. So I'll leave it up to number 15, what you want to do. I don't care, Grace. That's fine with me. All right, Grace, go ahead. What values if you're going to do law of sines?
So it would be B
Yep.
over sine of 40.
Okay, so you're going to use the bigger triangle?
Yeah, or maybe I don't have to do that.
Well, here's my concern. If you use the bigger triangle, you don't have another side from the bigger triangle. Like if you go B over the sine of 40, well, unless you're gonna add those two together.
Yeah, I don't have to.
No, that's fine. Go ahead. So 290 plus 186 will give me 6. I don't know. I haven't done that. What is it? 476. Okay. Well, what do you have to put that over now?
Sine of 50.
Good. Sine of 50. And depending on how you did it, you'll get one of two answers. They're both one apart, depending on how you did this. Pythag, what numbers you used. What do you get it this way, Grace? because I did it a different way. And you're either going to get 399 or 400, depending on how you do it. Okay. If you did it differently, there's some other ways you could get 400 out of that because you used a rounded answer. Other questions? Yes, Bella.
Can you use like rounded numbers?
If they've already been used in another part, yes. Okay, so now you're out to part C or D, and you want to use something from parts A or B that were rounded, that's fine, yes. But something like at this point here with the 441, no, because I'm in the middle of it. All right. Anything else? All right, I think I'm going on to number 8 now. Number 8. Which expression is always equivalent to sine x? And they give you this inequality here, which is angle x is between 0 and 90. That's another way of telling you that angle x is, if it's between 0 and 90, acute. It's an acute angle. All right. All right, so sine, this has to deal with the cofunctions. What's the cofunction of sine? Cosine. And we discussed, when are these two always equal to each other? If their angles are complementary, yes, add to 90. So if my angle is x right now, how do I find its complement? 90 minus x. Just quickly, I'm not going to do this one with you because I'm just making it up off the fly. But let's say I had cosine of 2x plus 3 equals sine of 5x minus 2. I don't want to set them equal. What did you just tell me about the angles if they're sine and cosine are equal? They're complementary. So I want to do 2x plus 3 plus 5x minus 2 equals 90. All right, I know it's very easy just to look at it and set them equal to each other, but their angles add to 90. Find a blank spot. A lot of people have been going to the last page and putting this at the bottom. This is not on there, and we need to go over this concept because I don't have a confident feeling about it yet. So all I need you to do, diagram only. Diagram only. That's all I need. Diagram only. You can put in the 15 and the 16 and the right angles. That's good too. All right, but don't worry about what it's asking for yet. Nothing. You don't even have to know what I'm going to ask. Just based on this diagram alone, I already know it's going to be what topic? Thank you, Hills and Sass. Why? Ready? What type of triangle is GHF? Right triangle. What's HG? HJ. Altitude drawn to the hypotenuse. Just by this diagram alone. Hey, I could even do, hey, ready? Let's get crazy. What type of problem is it still? Still. Okay, doesn't matter how I turn it. It's a right triangle with an altitude to the hypotenuse. It's a Hills and Sass problem. Everyone good there? Do you see any 30, 60s, or 45, 45s? So don't put your own in. All right, don't put your own in. I already know it's a Hills-Sass problem. All right, first thing I'm going to ask you for is the length of JG. We're going to find the length of JG. Identify the parts that are given to you. What do I call that part that's labeled 15? Out of all these here, what would I identify 15 as? A leg. What am I going to identify XJG as? Segment. I think we can stop right there. I think I know which one I'm going to use. If you gave me a leg and I'm looking for a segment, I got to use Hills. Can you identify the hypotenuse length in this problem? 5, can you identify the hypotenuse length? Thank you. I'm going to write x plus 16, but yes, 16 plus x. Leg, we've already identified. What do you know about the legs and hills? They're the same. Remember we called that the mean proportion? 15. And what's that S represent in hills? Segment, but I got two of them. Haley? The one next to the leg I'm using. So if I'm using leg 15, what's the segment next to it? X. There's hills. X squared plus 16x equals 225. Oh boy. Yes, I will give you quadratic formula, but not right now. I'm not. Move the 225 over. If anybody wants to play around and find two numbers that multiply to 225 but add to 16. Andrew. 25 and 9, do it. What about the signs, though, to make it add to 16? Thank you. Anybody want to x equals 9 and x equals negative 25? Anybody want to talk to me here? It is a side length, so can't have negative 25, only can handle 9. So that's what the segment is up here, 9. Second part of the question, find the length of HJ. There's the second part of the question. Find the length of HJ. Now what's HJ? It's an altitude. Discussion over. The only thing I can use with an altitude is SAS. What's a segment length? 9. Altitude we're trying to find. And is this different or same segments? Different. So the other one's 16. Y squared equals 144. So the value of y, 12. Yes, Jeff.
In the hills, why couldn't you use 16 as the segment?
Because it was not next. The S in hills represents the segment next to the leg you used. What leg did we use in the proportion? 15. So I needed to use the segment next to it. Okay. And also some of you may say, did I need to use SAS? No, you did not. You could have also used Pythagorean theorem on this triangle. Okay, if you wanted to. But make sure, hey, quick question before we go. If you use Pythagorean theorem on this triangle, where's your hypotenuse? 15. Okay, so it would be 9 squared plus y squared equals 15 squared. Questions? Whew, all right. You'll get the test when you come in tomorrow. All right, prep for it.